Hey guys, I'm Dave and this is Let's Click Photography, and this week we're going to be doing something a little bit different for the channel, and it's in response to a question that I got on last week's video, which was all about focal length. And that basically was, what does focal length actually represent? For this we're going to use the longest edge of a sensor, and we've got our sensor represented down the bottom here. Now for this we're using a scale of ×2. I'm using Nikon size sensors for this because Canon ones are a little bit weird for APS-Cs and they go into decimals of millimeters. Nikon make it much easier because their APS-C on the long edge is 24 millimeters. So for the sake of this, that's 48 millimeters, which would make it a little bit easier to see on this video. And then we've got a Nikon full frame, which comes in at 36 millimeters. And again, scaled that up ×2, which makes that a little easier to see. Now, because we've scaled that sensor size by 2, we also need to scale our focal length by 2. So as we measure out the focal lengths, I'll be doubling the focal length so that we can represent it properly with the sensors. And what focal length actually represents, what those numbers on your lenses, 35mm, 50mm, actually represent is the distance that the light converges to focus from your sensor. If we've got a 50mm focal length, that means that our converging light rays come in 50 millimeters away from the sensor. On here, 100 millimeters, because we're doubling the distance. And what we're going to do is we're going to have a blue pen here to represent full frame, and my red pen here to represent APS-C. And I'm just going to mark that. Now, what happens is our light rays, let's get our APS-C pen, converge exactly here. And when we're using a full an APS-C sensor, that means that, so that's the way our light rays converge, and then we go off, and that becomes our field of view. And that is 50 millimeters on a APS-C crop sensor camera. Now, if we do look at how that works on a full frame camera, there we go, we can see our APS-C there represented in the red. So that is our APS-C field of view. The blue represents our full frame field of view, and we can see that that is much wider. This is a cropped down version because we are using a smaller sensor. But what's really important to note is that irrespective of the sensor size, 50mm focal length is 50mm focal length. It never changes. So when we say things like, oh, that's a full frame equivalent of such and such, or APS-C equivalent of such and such, well, that's not right. 50mm is always 50mm because the measurement itself represents the distance from the sensor, and that doesn't change because of the sensor size. But what about equivalence? What about if we put a 75mm focal length onto our full frame? Would that match up with the 50mm on the APS-C? And with Nikon, that is 1.5 times smaller sensor, and we can see that it doesn't. So this is our field of view here on the 75mm. This on the full frame. This is the field of view here on the 50mm from the APS-C. Now, as you can maybe be able to tell there, if we go off into the distance, because of the angles of these lines, at some point they are going to converge. But after they have converged, after some time, we'll find that the field of view on the full frame actually becomes wider than the field of view on the APS-C frame. Lenses will always act differently. There is no equivalence on a full frame and an APS-C. There's only close as, and that isn't equivalent. Now, if that made sense to you and it was useful, click the thumbs up. And if you want to watch the video that was being talked about last week, then this is it here. I've been Dave, and this has been Let's Click Photography, and I will see you guys on the next one pretty darn soon.